Simplifying radicals. You did this in algebra. You do a lot more of it next year in Algebra 2. And they don't really have us go over this till now, even though many of the lessons we've done, they have their answer as radicals. Remember, a radical is, it's really not called a square root sign. The name of this is, it's a radical sign. They just call it a square root because there's square roots, there's cubed roots, there's fourth roots, and fifth roots, and so on. A cube root just means what number can you take 3 times to get this? 2. What number can you take 4 times to get that? 2. So the square root, since it's the first one, they just leave the 2 off. So if there's nothing there, it's considered to be a square root. But all of these are just radical signs. So when they say simplify the radical, if you remember, if you checked your answers before, sometimes they'd have an answer like this, 2 squared roots of 3. And when I told you just to round to the nearest tenth.
6.
No. 3 is 1.71 square root of 3 and so on. So what we're going to have now is some of your assignments say to leave your answer in simplest radical form. Some of them we can round to the nearest tenth. Now, what's coming up is the Pythagorean theorem stuff, which we've done many times. In order to find the hypotenuse, you got to take the leg squared plus the leg squared and square root it.
Are you reading calculators for this?
You might. So when we did this, it would round to 8.1. Now that's not an exact answer, that's rounded. So what they would put, this is the sign, it means approximately. That means this answer's been rounded. So if we want to leave this exact, they're going to say leave it in simplest radical form. That means don't put it as a decimal. So what you'd have to do is 4 squared plus 7 squared is square root of 65. So right now it's in radical form, we just don't know if it's simplest radical form. So the assignment we're doing today, it's kind of review. You did a little bit of it last year, like I said. Next year you do a lot of it. But what's nice in geometry is we only do square roots.
So how do you simplify the radical?
I'll show you in a second. To see if a radical can be simplified, you got to check. So to simplify any square root or radical, check to see if any perfect squares go into it.
So would that be like 9?
Yep. So the perfect squares, remember, are the square root of 1, which everything goes into that, so that doesn't do any good. Square root of 4 is 2. Square root of 9 is 3, and so on.
So any ones that have whole numbers is
Well, no, a whole number. No, these are whole numbers, but not any whole number, because 8 is a whole number, but it's not a perfect square. 4 times 4 is 16, so 16 is a perfect square. 25 is the next perfect square. 36, and so on. If you don't have these memorized, you don't need to because you got a calculator, but it just makes it a lot quicker. If you do know the first 12, 121 is 11 and 144 is 12. So, what you got to do is, this is where you would want a calculator. if any of these numbers, if any of these, and it goes on and on forever, you know, goes into that, then it's not simplified. So remember, it's no use checking one because that doesn't do anything for it. The easiest thing to do is if it's a big number and you don't recognize it, punch it in and just do square root. It might be a perfect square. Like if they had the square root of 529. If I square root that, it turns out to be a perfect square. That's just 23. So now it's simplified. Square root of 65, we know it's not a perfect square. So then you start at that number and work backwards. Does 49 go into it? Does 36? Does 25? 16? If you don't know, just take 65 divided by 16. No, you get a decimal, 4.0625. Does 9? Does 4? No. So, since none of those go into it, this is simplified. Okay? So you can't do anything with it. You would just leave your answer to square root of 65. So, some of them that can be simplified. Okay, so for 70, now remember the only numbers you're worried about going into it are the perfect squares. So I know 64 doesn't, I know 49 doesn't, 36 doesn't, 25 doesn't, does 16? Take 70 divided by 16, no, you get a decimal. Does 9? Does 4? 70 divided by 4, I don't think so. No, you get 17.5. So that's simplified. For 200, what perfect square goes into 200? 100. Now, if you don't catch it right away, you might use 25, you might use 4. If you don't get the biggest one, you just got to keep simplifying down. So I'll just do the 100 to begin with. So what you do is you split this up. In order to get 200, I would take the square root of 100 times the square root of what? 2. 100 times 2 is 200. And then this is where the simplifying part comes. What is the square root of 100? 10. So the answer is just 10 square roots of 2. Okay? Now, if you wouldn't have noticed that 100 goes in there right away and you would have chose 25, 25 times 8 is 200. Square root of 25 is 5. So that makes 5 square roots of 8. You're close, but 8 is not simplified. What perfect square goes into 8? 4. So the 5 would stay there. The 8 you'd split up into square root of 4 times the square root of 2. And then the square root of 4 is 2. So 5 times 2 is 10 square roots of 2. Okay? 30. Do any perfect squares go into 30? That's one that looks like it should simplify, but none of them do. So that one's simplified.
Lynette Schwartz, dial 101, please. Lynette Schwartz, dial 101, please. Thank you.
64. 8 goes into it, but 8's not a perfect square.
So 4 probably.
4 does. If you take 64 divided by 4, you get 16. So,
4 goes into 16.
what's the square root of 4? 2. And what's the square root of 16? 4. So what's the answer? So here you should have used your noggin a little bit right away. Square root of 64 is a perfect square, it's 8.
I mean, we knew that, we just
Oh,
wanted.
you knew that?
We wanted you to go through the work, we understood it.
All right. Okay, these two are a couple that are pretty popular. 125, which perfect square goes into it? 25 times 5. So what's the square root of 25? So it's just 5 square roots of 5. 80. You see this one quite often for some reason in the problems we do. So I'll just, 16. It's not an easy one to think of, but 16 times 5. So that would simplify to 4 square roots of 5. So again, what we're going to be using this in the next chapter is we're doing right triangle stuff.
Do you always put the non-square
Yeah.
number first?
You don't have to, it's just easier to read and write.
They could mix it up like, yeah.
So when we're solving for right triangles in the next chapter, this one, use the Pythagorean theorem, it would be 20 squared minus 8 squared, because we're looking for a leg. Remember, if it's a leg, you subtract. If it's hypotenuse, you add. So normally what we've done in the past is we've just did this on the calculator, round to the nearest tenth. Now they're going to want it in simplest radical form. So 20 squared minus 8 squared is 336. So now we got to simplify that. We got to figure out a perfect square that goes into that. 16? I tried 64, that doesn't work.
I'm trying.
36, nope. Yeah, 16 does work. 16, all you do is take 336 divided by 16 and I got 21. So that means this would simplify to 4 square roots of 21.
Is this chapter 9 or you ready to send us the book?
Yeah, but we're not in it yet. I got a worksheet for this. Because they expect you just to know this from what you learn in algebra, so it's not in the book. So that's why we're going to spend one day just doing a worksheet on this, and then we'll start the book